In this lecture video, I'm going to show us how to perform a chi-square test in SPSS. Now we want to have a look at the statement of hypothesis. For a chi-square test, the hypothesis is as follows. The null hypothesis is saying that there is no association between the rows and the columns. So the rows and the columns are not associated. In other words, we can say that the rows and the columns are independent. So the rows do not depend on the column do not also depend on the row. That is what the null hypothesis is saying. So for simplicity, we can say that there is no association between the rows and the column, or the rows and the columns are independent. While the alternative hypothesis, which is opposing the null hypothesis, states that the rows and the columns are not independent. In other words, there is an association between the rows and the columns. So whatever affects the column could also affect the rows. So we're looking at in this case. So for us to pass the judgment, or in other words, for us to make a decision and draw conclusion, we need to analyze the data. We need to conduct the chi-square test. And after conducting the chi-square test, we can now make our decision and draw the conclusion based on the output of the test. All right. In particular now, we have this case we want to look at or to solve. Now we have employment status and gender. For the employment status, we consider a situation where we have unemployed, retired, and employed, which is at the column. Then at the row, we have the gender. So the gender here could be male or female. Now the question is that, does it really matter when it comes to the employment status? Does it really matter about the gender, whether it's male or female, or it doesn't matter? That is the work we want to do now. So the work we want to do is to conduct the test to see whether the employment status is associated with the gender, or if there is no association between the employment status and the gender. In other words, whether there is dependence or independence between the employment status and the gender. All right, so to do this, we know that whatever we have at the row, by the assumption, this table is called a contingency table. So if we follow the assumption of a contingency table, then the row total will be equal to the column total. And of course, that will give us the overall total. So what I mean is that if you take the total for each row, total for each column, then the sum for the row will be the same as the sum for the total for the column. So row sum equal to the column sum, and is equal to the overall total. That is a grand total, where you sum all this from the contingency table, where you have the values 41, 385, 477, 80, 290, and 499. So if we take the row total, we also take the column total, then the sum for this row total will be equal to the sum for the column total, and it will be equal to the overall total, which is the grand total. So we call it the grand total. All right, in particular, the statement of hypothesis for this problem is that there is no association between gender and employment status, versus there is association between gender and employment status. Does it matter or it doesn't matter? Let's proceed now to run the test. But before then, you need to do this preliminary analysis. You could have this. Now, for the gender, we have two rows, male and female. This could be row 1, and this could be row 2. Likewise for this, if you move to the employment status, it could be column 1, we have column 2, and column 3. So you could see everything we have here, from the first to the last. So for the column, we have 3 columns. 3 columns. And for the rows, we have 2 rows. So 2 rows and 3 columns. For the row 1, male. Male here, I have value here for unemployed, retired, and employed. So all these values fall under row 1. Therefore, for the gender, we will assign 1, 1, and 1. I could make it bigger if I want. That's fine. Then for row 2, we have female, and the female for unemployed, retired, employed fall under row 2. And that is why here will be 2, 2, 2. So that's sorted for the gender, row 1 and row 2. Moving on to the employment status, you could see that we have 3 values, column 1, column 2, column 3. So in this case, we will have this value corresponding to male, this value corresponding to male, this value also corresponding to male. So these 3 values are under row 1. So in this case, we will have 1, 2, 3 correspondingly. Then the next again, 1, 2, 3. So we have 1, 2, 3. So that's sorted also for the employment status. 1, 2, 3, 1, 2, 3, 3 columns. Then next is the frequency. The frequency, we have to start from this first value and we take it in row order. So when we're done with the first row, we'll move to the second row until we list all the values. So we have 41, we have 385, and we have 477. Again, we have 18, we have 290, and we have 499. So we have all this. Of course, we could also format the table if we want. Highlight, right click, you go to format cells, border, outline, inside, and OK. And that's all done. So now we are ready to impute them in the SPSS. So let's impute these observations into the SPSS editor. So we have the values for the gender 1, 1, 1, and then 2, 2, 2. For the employment status, we have 1, 2, 3, 1, 2, 3. And then again, for the frequency, we have 41, we have 385, we have 477, we have 80, 290, and 499. All right, so we need to go ahead again to do further work with what we've got. In this case, What do we do in this kind of analysis? All right. So what we need to do now, we'll move from the data view screen to the variable view screen. If by what we have now, we go to the view, and then we click on value labels, nothing will come out because we haven't done anything at all. We could go back again, value label is still as it is. But if we move to the variable view screen where we need to tell SPSS to do some task, because SPSS does not understand what we are doing now. So we tell SPSS that the variable name for the first one is gender. That the variable name also for the second one is employment status. And the variable name, when you leave a gap, SPSS will not accept as a variable name. So we have to follow the format. Employment. You may use hyphen. That's fine. Employment status. That's fine. So it's accepted. Then we have the frequency. So this is all done. Then the type is numeric. So we're happy with this. Decimal. We don't need any decimal actually. So it should be 0. All zeros. And if you go back to the data view, you see that the decimals have disappeared. So no more decimals. So what next? Go back again to the variable view screen. Here we have the gender as normal, then employment status. I could use this abbreviation. Then also the frequency. Then for the categorical part, of course, the gender is categorical. So we need to indicate 1 for the gender is male. We add it. And 2 is for female. We add it. And I will proceed to say OK. For the employment status, we have 1 for unemployed, 2 for retired, and 3 for employed. So we have unemployed, retired, and employed. Okay. Then for the frequency, we don't need to do anything because this is a quantitative variable. It is not categorical. We can only assign those values if the variable is categorical, that is qualitative. But where it is quantitative, we don't need to assign any value. Moving on to the next aspect, of course, there are no missing values. There's the column size, and then they align to the right. If aligned to the left, you see what will happen. For instance, for gender, they go back again, you will see that it will be at the left, while these are the right. You can go back again and align to the right. So it's not serious. You could also take align to the center. It's a matter of choice. So go to nominal. That's fine. The measure for the gender is nominal, so it's accepted. For employment status is also nominal, and for frequency, it is scale. So we're happy to do the analysis now. So we want to run the analysis. Again, you could see now we have the male, male, female, 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 unemployed, retired, employed, unemployed, retired, employed, and then we have this. So before you do the analysis, you need to let SPSS understand that both gender and employment status are weighted by the frequency. So they tell SPSS that gender and employment status are weighted by frequency. We go to the top icon and then click on data. From data, scroll down in the drop-down menu to the last icon. This is weight cases. We could say the last item in the drop-down menu, which is weight cases. So click on that weight cases. We want to weigh cases by the frequency. But first of all, what you are seeing here is do not weigh cases. No. By default is do not weigh cases, but we actually want to weigh the cases to let SPSS know that the frequencies here are the frequencies for the gender and the employment status, frequency distribution. So we go to weigh cases by, it's not by gender, it's not by employment status, it is by frequency. And then you click on this arrow so that it will move frequency to the frequency variable box. And from here, we could proceed. Okay, so now SPSS understand that we are weighing both gender and employment status by the frequency. So we are set for the analysis. We go to analyze. Now, if you move to analyze, you'll be wondering, what do I need to do regarding the chi-square? You could go to descriptive. From descriptive, you could even go to explore. You could go to crosstab. All of these could also be helpful. Now, if you go to descriptive, for instance, then you check, do you have statistics for that? Look at it. No, you don't have what you want. So you now leave that. So when you move to this first descriptive, that is from the drop-down menu for this analyze. Descriptive, then next, you can go to explore. I could also take us to crosstab. So let's deal with the explore now. So if you move to explore and you check, for instance, the statistics, you check, what will you see there? Do you see chi-square? No, no chi-square. If you move to plot also, any chi-square? No. So you could see, that is why it's good to double check there is nothing wrong to check where exactly you get what you are looking for. If you go to crosstab, of course, you should be able to. So if, okay, let's assume now we'll bring in the variable first and see the difference. If we have employment status and then factored by gender, if we factor it by gender, then go to statistics, check, we do not have chi-square also, just to let us know. So we leave this. What we want to do, in order to get the chi-square result, we go to analyze. From analyze, move to descriptive statistics. And from descriptive statistics, go to crosstabs, because we're cross-tabulating. Instead of going to descriptives or going to explore, that is for other purposes, not for chi-square test. So for chi-square test, from analyze to descriptive statistics, then crosstab. From this crosstab, we need the rows and the column. So for the row in this case is gender. It will not alter the result, even though you move employment status to row and gender to the column. It will not alter the result. But let's do it in this way. Row, gender, then employment status is the column. Now, when you go to statistics, check what you could see here, chi-square. So you could see under the cross tabs, you will see chi-square, where we can perform the chi-square test. We also have correlation if you need it, contingency coefficients, and all of that. But if you don't need all of that, you could leave it, and then you proceed, continue. What about cells? Do you need expected values and observed values? If you need the expected values also, you can click on this. If you also need the unstandardized, standardized, or adjusted standardized, and then percentages, row, column, total, and so on, you could also tick the respective boxes. But in this case, we don't need them. And so proceed to say continue. Then what follows? Display clustered bar charts. If you need that also, you can tick so that it will display, but in this case, we don't need it. So we leave it. And then we proceed to say okay. And you can see now the chi-square result. So clearly we can see the chi-square result. Now, this is the cross tabulation where we have the expected values and the observed values. So for each observed value, there is a corresponding expected value that is computed using the formula O minus E all square over E square. So if this is done, then of course, we can obtain this result. But you could see that the software makes it faster than doing it by hand. All right, moving on to the chi-square test, which is the result we want. This very result is what we want. From this result here, now the Pearson chi-square, the likelihood ratio, linear by linear association, and then the number of valid cases. Another important aspect is to be able to interpret the result from the software, because sometimes you may use the software to do the computation and you may be wondering what the results actually stand for. So it's good to understand so that you can provide a correct interpretation regarding the result. So here now, going to the Pearson chi-square, you can see the test statistic, which is 25.794. So if we are to check the tabulated value, then we have to compare that tabulated value, which is also called the critical value, with this with this calculated value, which is the test statistic. The test statistic is the one calculated based on these values, but the critical value is the value from the table at row minus 1 times column minus 1 chi-square degree of freedom. And then we're looking at 5% significant level in this test. This is a test at 5% significant level. So in this case, to go straight to the point, if you want to use the table, that's fine. Then you have to compare the tabulated value or the critical value with this test statistic. And if the test statistic is greater than the critical value, then you can reject the null hypothesis in favor of the alternative hypothesis and draw the conclusion that there is association between the rows and the column. Or in other words, you can say in this particular situation, if that happens, that is, if the test statistic, which is this value, is greater than the critical value obtained from the table, the chi-square table, then you can reject the null hypothesis and conclude accordingly here from what we have that there is association between gender and employment status. But let's see if that is the case if we're using the p-value to pass the judgment. Of course, for the degree of freedom, we have 2, which is correct. Degree of freedom is 2, because in the first instance, you have 2 minus 1, which is 1. The second instance, we have 3 minus 1, which is 2. So 1 times 2 is 2. That's why the degree of freedom is 2. And then, of course, If you move to the p-value, in this case, SPSS record the p-value, which is the probability of rejecting the null hypothesis when it is true. It recorded as asymptotic significance, two-sided in this case. So it is a two-tailed test. That's why it is two-sided. All right. We have a p-value less than 0.05 by the Pearson chi-square, which is most widely used. Then we also have the likelihood ratio is also less than 0.01. So we can see that there is a strong statistically significant evidence to reject the null hypothesis in favor of the alternative hypothesis. So we can reject the null hypothesis as our decision, and by our conclusion, we can conclude that there is a strong statistically significant evidence at 5% significant level that gender is associated with employment status. Or in other words, we can say that there is association between gender and the employment status in this case. So what we've done, we've rejected the null hypothesis in favor of the alternative hypothesis. So the employment status is associated with the gender, where we could have 41, 385, and so on. In this case, what is happening at the column is affecting what is happening at the row. They are associated. They are not independent. Rather, they are dependent. So employment status could depend on gender. In this case, it depends on the gender. Is it that when you are a female, there is a high likelihood that you will not be employed, that you could retire, that you could be employed? That's what we are considering. Or when you are a male. So this analysis from the evidence we obtained shows clearly that we can reject the null hypothesis in favor of the alternative hypothesis at 5% significant level. That is based on the evidence provided. And we can conclude that there is an association between gender and employment status. So thank you so much for your attention. Thanks for watching this video. And if you are happy with the video, please leave a message at the comments. When you watch it on YouTube, you could comment on it if you are happy with it or not. And then also, if you are happy with it, particularly, you can like the video. And of course, in doing that, that will keep me motivated and happy to produce more videos and share it across the globe. Thank you so much for your attention once again. And thanks for watching my video. You're highly welcome to my YouTube channel.